Thank you. Dangerous making predictions and then having them read back to you on stage. It's still just the beginning of 2023, so hopefully that will come true. Thank you very much for inviting me. I'm super excited to tell you about what we're doing. So this is the Buck Institute. I run a lab there. I'm a neuroscientist by training, and so my lab is really focused around trying to understand how the brain communicates with the rest of the body. So unlike what Sophie talked about with the wired communication between neurons, we work on this kind of Wi-Fi communication. And I'm actually not going to talk about that. I'm going to talk about some other stuff today. But that's my lab. We're 20 miles north of San Francisco. Come visit if you're nearby. The Buck Institute really focuses on aging, trying to understand basic mechanisms of aging. And the reason to do this is that your age is the #1 risk factor for most chronic diseases of the developed world. So for cancer, for example, your age is a much bigger risk factor than any genetic mutation you might have. And as such, we think about aging as a public health pandemic. So soon there are going to be more people over the age of 65 than under the age of 5 for the first time in our history. And the goal really is to extend health span, not lifespan. So what we're thinking about here is just trying to extend the number of years that someone is actually healthy, not to extend overall lifespan. And so as we're doing this, we're all familiar with this graph of this kind of functional decline that happens across our organ systems with age. There's something that really falls off this curve, and that is the female reproductive system. And so I want to acknowledge that aging does happen in the male reproductive system. The difference here is that aging in the male system is synced up with aging in the rest of the body. And so ideally, my moonshot goal would be to make that red curve look like the blue curve, just to make it so that aging in the female reproductive system is synced up with aging in the rest of her body. Now, a lot of people will ask me, well, women live longer than men, so is this something we really need to take care of? And it is true that life expectancy of women is much higher than men, on average 5 years across every country where we've looked at it. However, women spend more of their lives in really poor health, and this is directly related to reproductive aging and aging in the ovaries. So ovaries are, and when I say women and female, I just want to acknowledge that I'm talking about anybody who has ovaries. So I'm also talking about people who are not women identified. But ovaries are aging at about 2.5 times the rate of the rest of the tissue in our body. And if you think about that, what that means is that when a woman is in her late 20s or early 30s, when most of her systems are functioning at what could be described as peak performance, her ovaries are already showing overt signs of aging, and the medical community actually considers them to be geriatric. It's a great term for someone who's in their 30s. But we think about ovaries kind of like the canary in the coal mine for aging. So for the men in the audience, if we can understand the mechanisms, like really what is driving ovarian aging, then this is going to give us clues about aging in the rest of the body. So females, humans at least, are born with all the eggs that they're ever going to have. So before a female fetus is born at 26 weeks gestation, there are about 6 or 7 million eggs in her ovaries. And so what that means in practice is that even though I was born in the late 1970s, the egg that I came from was made in my grandmother's womb in 1956. So it's a little like sci-fi when you start to think about the matrilineal lineage. But men can make sperm, millions of sperm every day, so there's a big difference here. And this is a graph that most women are familiar with at some level, but it essentially is showing that egg quality and quantity declines over time, and this is what we call reproductive span, and when a woman runs out of eggs, this is what we consider menopause. But this is not, at least at the level of the individual, this is an average. This is not true at the level of the individual. So female fertility is one of the most multifactorial and complex signatures in all of human health, and we need to treat it that way. So at the level of the individual, young women go through periods of infertility that are unexplained. Older women go through periods of hyperfertility, and so this is a place where individualized, personalized care is going to become really important. And menopause, which is essentially when a woman's ovaries stop working, has a really profound effect on overall health. I alluded to this earlier. But thinking about menopause from the perspective of health and not fertility, I think is one of the key things that we're trying to reframe in terms of thinking about women's health. So going through menopause has this dramatic impact on risk of heart disease, for example. So after menopause, a woman has a 4-fold increased risk of cardiovascular disease. Risk of osteoporosis goes up, risk of cognitive decline, risk of arthritis, risk of all sorts of things, autoimmune disease. I could go on and on. But we really think about this as an issue of equality. So the fact that women are going through this reproductive decline in the middle of their lives really does impact every aspect of a woman's life, right? So from the minute I went through puberty, whether or not I wanted to have a biological child, I was thinking about this ticking biological clock in the back of my mind. And quite frankly, I didn't even understand that there were going to be all these negative health consequences that were going to happen to me, hopefully not too soon, but in the next 5 or 10 years. So I think many people don't realize that a woman's reproductive span, which is the age at which she goes through menopause, is linked to her overall lifespan. Now, this is a correlation. We have absolutely no idea what's causing this, but it's a real correlation. It's been shown in many studies that a woman who goes through menopause later will tend to live longer, and a woman who goes through menopause early will tend to die younger. And I want to draw your attention to the x-axis here. Age at menopause, natural age at menopause, is something that spans 14 years to be called normal. So if you go through menopause before age 40, that's considered early. If you go through menopause after age 54, that is late. But when we're talking about something in human health, there's nothing else that spans such a large time range. So why it's so variable at the level of the individual, I think, is something that, if we could understand, would tell us a lot about what the underlying causes were. Now, for those of you who happen to have a Y chromosome in the audience, it's also true that brothers of women who go through menopause later tend to live longer. So there's a genetic component here that we don't understand, but which is important for everyone. So now's the moment when everyone who is a male is going to start texting their sister to find out how old she was when she went through menopause. And humans, human females at least, are very odd. This is a strange reproductive strategy. In the animal kingdom, it's just us, a few species of whale, maybe giraffes, maybe one species of New World monkey who go through menopause. And so what this tells me as a scientist is that it's not a biological imperative, it's not necessary. And so, from my perspective, let's get rid of it. So I'm bringing you back to this picture because I think we want to reframe the narrative, but we also want to talk about, what is happening here, right? We understand the downstream consequences. It's very clear in terms of fertility and miscarriages and infertility. But what sets it in motion, what it is that drives it, we have absolutely no idea. We don't understand why it's happening so early. So these are the kinds of things we want to find out. And I'm just going to quickly say, I think everyone in the audience is probably familiar with this, but women's health in general is underfunded. So on the left is funding from the National Institutes of Health, which is the largest biomedical research funding body in the US, from 2018. So the budget was like $27 billion, and about 15% of that went to all of women's health from conception through death. And of that, basically a rounding error, talking about maths, basically a rounding error was devoted to female reproductive aging, less than 0.1%. Now last year, biotech investment in this space was actually up quite a bit, 10 times higher than it was in 2017, but still less than 4% of the total investments. And this was actually quite generous, what I considered biotech investment in women's health. So if we dig into those NIH numbers, I showed you 2018, which is the first bar here. What you can see is that there's a positive trend. So I want to make sure that, that I leave you with positive feelings about what's happening. So the amount of funding is going up, but as you can see, it's still a ridiculously small percentage of the overall NIH budget. So I spend a lot of time, actually, I'll talk about this in a minute, trying to lobby not just the NIH, but other funding bodies to try to put more money towards this goal. And the other reason that I think, aside from a lack of funding, that we're where we are right now, is that the male body really has been biology's baseline. So clinical studies, but also biomedical studies, that NIH only mandated that grantees had to use female animals in their studies in 2016. So that's like just over 5 years ago. So what that means is that we have basically a century of preclinical data which is conducted and collected only in males. And there's a huge problem with that, which is, I think, illustrated well by this fact. If we're only collecting data on male animals and in male people, then what happens is a lot of the vulnerabilities that are specific to females are lost. And so this is data from drugs that were pulled from the market. So these are drugs that were approved by the FDA, then pulled from the market because of safety concerns. Was entirely, 80% of them were pulled because of adverse effects in women. As it turns out, women and men are different. There's also a cost associated with this, which I won't go into in detail. But essentially, 2025, the National American Menopause Society is predicting that over 1 billion women will be in menopause or past menopause. So that's like 12% of the population. And the costs that are associated with those increased medical care bills, and also due to productivity loss, due to the vasomotor symptoms that we haven't talked about that happen around menopause, are really profound. And I wonder, if we really, as a society, understood these costs, whether we would be doing more. So the global market, for those of you who care about investment, the global market for women's health is big and it's getting bigger, so over $40 billion. But of that, last year, 38%, almost 40% of that market was the menopause market. So this is something that you should really pay attention to, because this number is expected to double by 2030. Now, despite that, only 5% of the startups that were focused on women's health are addressing menopause. And that's flying in the face of the data. So 80% of the women who make healthcare choices are of a menopause age, right? So if you're an investor, this is something to really keep in mind. And most women are experiencing symptoms. So this is a place where there's a lot of room for innovation and investment. I put here some names of companies. This is not an exhaustive list. But what I wanted to draw your attention to is the stuff on the top is apps, virtual care, devices, products. At the bottom, there's very few companies that are actually focused on therapeutic interventions. And that is because, and so they're treating the symptoms, these companies, not the causes. That is really because we have to answer these questions. So we fundamentally don't understand. I'm coming back to what I started with. We don't understand what drives reproductive decline. We don't understand why it's so variable at the level of the individual or why it correlates with overall lifespan. And I think these are the questions we need in order to drive the innovation towards therapeutic discovery. So this is what we're focused on. A few years ago, we started this Global Consortium, which is a nonprofit, which is dedicated not necessarily to funding science, although that's what we're doing right now. Our goal really is to just facilitate and accelerate taking those discoveries that happen in the lab and moving them into women's hands faster. So right now, from my perspective, that means funding the science. So we fund grants. This is a very busy slide and you don't need to read it, but this is all the stuff we do. So we fund grants to the scientists, but then we also spend a lot of time trying to build the ecosystem around this new field of science. If we're building it from the beginning, we can do it differently. And so for me, that means bringing all of the stakeholders into the same room. So I spend a lot of time getting people who don't normally talk to each other to interact. That means clinicians talking to scientists, funders talking to early stage founders and things like that. And we spent a lot of time building out resources for our grantees, which you can read about on our website. We gave away the first round of grants in 2020. We're giving away another one next week, actually. And we'll be doing this every year going forward. And this is truly just dependent on how much money I can raise. So these are the kinds of projects that we funded. And really, we're casting a wide net because we don't know where the answer to that question is going to be. But there's already been a lot of really exciting work that's happened in this space. And I wanted to just leave you with a positive message, which is that since 2020, there's been a huge increase, not just in the amount of science that's been done and the number of companies that have started, but also in terms of just public perception and the conversation that's happening in the society in general. So it's a positive message. And the future outlook, I think, is good. We're building a lot of tools and resources, which, again, I'm not going to go into detail on. But the last thing I wanted to say is that for those of you in the audience who have an interest in longevity or in aging research, as many investors do. I spend a lot of time thinking about this because I'm an aging researcher. There's kind of an elephant in the room, which is how do you test an intervention that's supposed to extend longevity in a human, right? We live 100 years. How do we do that? So here is a human model of accelerated aging, right? Right now, if you have a longevity intervention that you want to test in the clinic, you use dogs or flies or worms or mice or monkeys or some combination of those things. But here is a human model where you could do a clinical trial in a healthy woman in her 30s, which might last 3 to 5 years, with really simple endpoints, things like bone density, hormone levels, pregnant, not pregnant, really tractable. So I put this up here just as a thought experiment for those of you who think about these kinds of things. And finally, I just want to thank my team at the consortium and also our funder. Our major funder right now is the Biacco Foundation, and they've been incredibly generous and also very prescient in understanding this was an important field of science to study. And the more money that we can raise, the more grants we can give away, and the faster we can make this happen. So if you know any philanthropically minded people who have an interest in this space, please send them my way. That QR code will take you to my contact info. Thank you for listening.